For this video, let's practice finding angle measures in a regular polygon. So for number 1 in the diagram, ABCDE is a regular polygon inscribed in circle F. Find each angle measure. So I see for this first one, I want to find the measure of angle AFB. So I want to find AFB. I want to find what this angle measure is. And so first I need to recognize what type of angle that is. And we learned in our last video that an angle that's formed by two radii, which I see these both are, these red lines, is called my central angle. So this is my central angle. And we learned that the central angle, you can find it by dividing 360 by the number of sides. So I'm going to say this is equal to 360 divided by a number of sides. Well, the number of sides I see on this shape is 5, so we'll have 360 divided by 5. And when I do 360 divided by 5, I get 72 degrees. Okay, now I want to find the measure of angle AFG. So I have AFG. So I want to know what this angle measure is right here. I'm going to go ahead and redraw this triangle right here. So we can look at a little bit of a bigger picture. So we found that this whole angle right here is 72 degrees, but now I want to know what this angle measure is right here. Well, I see with this triangle that I have that since BF and FA are both my radius, they're going to be the same measure. So that means that these two sides are congruent. And so that means I have an isosceles triangle. So that means that these two angles are congruent. And we learned from a unit a while back that when I have an isosceles triangle and I have a segment here that's perpendicular to the base, that this segment is actually bisecting this top angle. So that means that these two angles are also congruent. And so I know the whole angle here is 72 degrees, and I know that this angle is being cut in half. So that means to find the measure of angle AFG, I'm just going to take half of my central angle. And that is because of these two angles right here are congruent. So this is going to equal to half of 72. And when I divide 72 by 2, I get that this becomes 36 degrees. So I have that this is actually 36 degrees. Now I want to find the measure of angle GAF. So I want to know what this measure is down here. Well, if I'm looking on the right hand side, I do have my triangle, a triangle right here, a right triangle. I know two of the angle measures, so I can use my triangle sum theorem to find the measure of the third angle. So that's going to be that this is going to equal to 180 because all of the angles of a triangle add up to 180 minus my 90-degree angle minus measure of angle AFG. So I get 180 minus 90 minus 36. And when I do that, I get that this angle will be 54 degrees. Okay, let's try another example. So in the diagram, WXYZ is a square inscribed in circle P. Identify the following. So at first I want to identify the center. Well, we learned in our vocabulary that the center of the polygon is just going to be the center of the circle. And so I see that's going to be point P. Next, I want to identify a radius. So remember, the radius goes from the center to a point on the circle. Or in other words, it's actually going to go to one of the vertices in my square right here. And so this one I have two radii I could choose from, and that's going to be PY, or you could say PX. Next, I'll identify the apothem. The apothem is going from the center to the side of the polygon, and so that's going to be PQ, and it's also going to be that side that is perpendicular. Then lastly, I want to identify a central angle. So remember, the central angle, it's formed by two radii. And so my two radii are PX and PY. So that means that my central angle is going to be angle XPY. Okay, now for this last example, we're going to find the following angle measures again. So first I want to find the measure of angle XPY. Well, we just identified that to be the central angle, and I know to find the central angle, I just need to do 360 divided by the number of sides. So here I have 4 sides. And so when I do 360 divided by 4, I get 90 degrees. Next, I want to find the measure of angle XPQ. So I'm going to again redraw this triangle down here. So I want to find the measure of angle XPQ. So I want to know what this measure is right here. Well, I know that these two angles right here are congruent because of this being an isosceles triangle. So I know that this measure is just going to be half of my central angle. Well, my central angle we just found to be 90, so this is going to be half of 90, which comes out to be 45 degrees. So I found that this angle is 45 degrees. Since these two angles are congruent, that means that this angle is 45 degrees. And now I want to find the measure of angle PXQ. So I want to know what this angle is right here. Again, I have a right triangle, and I know by the triangle sum theorem that all the angles of a triangle add up to 180. So this is just going to be equal to 180 minus my right angle 90 minus the angle XPQ, which is 45. And so I get that this angle is also equal to 45 degrees.